Assalamualaikum warahmatullahi wabarakatuh. First of all, my name is Aina Amira binti Khairul Nizar. So today I will present a quick one for Rehabilitation Centre for Endangered Marine Species. Firstly is about precedent study synthesis, which comprise from 3 aquarium centre. They are Blue Planet Aquarium, located in Denmark with the concept of the mimic of swirling water. Next is Coastal Marines Research Centre at El Tabo by Martin Hurtado. And lastly is Antalya Aquarium located in Turkey, designed by Bahadir Kul Architects. The first synthesis is building harmonies with surrounding topography, which include the sea and beach. Second is to implement natural ventilation and natural daylight. Besides installing rainwater catchment for rainwater harvesting, the rehab also require large space at entrance to ease the visitor to gather. Others are using seawater as direct cooling and having a centrifugal space as navigation hubs. Moving on to the case study synthesis, as the Rehabilitation Centre is designed for fish, there is the need to provide the aquarium tank with suitable environment for particular fish to adapt. Lighting also plays a crucial role to exhibit the fish and create the environment underwater for the fish. Next, each tank requires life support systems, which are aeration, filtration system, water heater or chiller to keep the temperature within the ideal range. For building structure, the most suitable material used in coastal area is reinforced concrete, as it is durable and non-corrosion. Meanwhile, friction pipe foundation is needed for coastal building. Fish chosen for the Rehabilitation Centre is the groupers. Groupers come in various types, and the most common in Malaysia are red-tip grouper, Malabar grouper, and tiger grouper. From all these species of grouper, we can conclude that their habitat can be found at coral and rock area. Facilities needed for the hatchery process involve storing fish feed, laboratory room for tests, storage room for maintenance, and pump area. Moving on to the site study synthesis for Site A. Site A is located approximately 300 meters from INOSEM with a total area of 4,000 square meters. Wind direction come from north and northeast for the sea breeze. Firstly is to install fences to prevent from wild and solar panel for renewable energy. Another one is to propose entrance from INOSEM Road. Next is to use reinforced concrete as material and glass wall for surrounding view. As the site is surrounded by trees such as palm and rue, utilize the tree as natural shading. And lastly is to have opening towards wind direction to maximize ventilation. Next is the SOA. We have admin and public facilities as the public spaces, seminar room and library for the semi-private spaces, office, lab, storage, and hatchery as the private spaces. The public space was determined by the accessible road of the entrance coming from INOSEM. The concept for the rehab center chosen is the S-curve, which derived from the 3 elements of nature. Sky represent air, sea represent water, and sand represent earth. Besides, the S-curve gives the effect of movement of wave and wind and the emotion of serene. The principle of design are rhythm and repetition of shape. The S-curve acts as a connection from one circle to another. The circle represents 2 spaces, which are private and public spaces. Lastly, forming radial organization from each space. For the design development, firstly, exit toward best view prior to the space that need a view. Second, exit from entrance to the view to determine circulation. Third, axis of wind direction coming from the sea breeze and land breeze. Fourth, 2 circles represent 2 separate spaces, which are public space and private space. Next is to implement the S-curve concept to design, along with the axis from the site context. 2 separate radial organization for room in private and public spaces. Lastly, determining the size of each spaces required and creating hierarchy by size. And this is the progressive model starting from axis combining with the consortium model that implemented into the design. Here is the bubble diagram. The ground floor emphasizes on public space and on the other side is for private spaces. Meanwhile, semi-private spaces are located on the first floor. This is the initial ideas for the space planning: open circulation for natural ventilation and daylight, cafe facing greenery and sea, lobby directly from parking area for entrance, exhibition near to the services for easy maintenance. For private spaces, office facing the best view and located opposite to the loading area for privacy. Lab and hatchery adjacent to each other to ease research Service room is away from library and office to reduce the noisy sound coming from the pump. From the side, there are two accessible roads. The first one is mainly for the visitor and staff that directly connected to the parking area. Second is for authorized employees that use the side of the building as entrance to ease the loading process and maintenance tasks. Here is the floor plan in the side boundary. This is floor plan showing spaces inside the building. User go to the entrance directly to the lobby. From the lobby, we can go to the exhibition, cafe and musola. The toilet located adjacent to the lobby to ease the circulation. Going upstairs, there are library and seminar room for the educational purpose. There is the link that connect public spaces to private spaces that is in open circulation to have cross ventilation and maximizing natural daylight. Private spaces located at the end of the site as for privacy purpose and accessible for the employees coming from the behind. The outdoor facility include parking area that can fit for 35 cars, landscaping and also pump area in the service room. There is also sedimentation pool that allows suspended particle to settle out of water taken from the sea and retention pool to improve water quality. The elevation emphasizes on the use of glass wall on semi-public room that will filter and throwing light into the building through timber cladding, which is for library and seminar room. It also shows the rhythm of the timber facade to show movement. Blue color is for public, while green for private spaces. For the section, the open circulation between the link of space create cross ventilation inside the building, allowing sea breeze to come into and warm air going out from the building. The structure for this building is concrete post and beam as it is durable, strong and anti-corrosion, which suit best at the coastal area. And this is the mock-up model from different sites showing the S-curve and the mimic of fish with facade design. The construction method is to apply friction pipe foundation. Friction pipes develop most of the pipe bearing capacity by shear stresses along the side of the pipe and are suitable where harder layers are too deep. Next is constructing the building by using reinforced concrete post and beam and CMU block for the curved wall, glass wall for the view with a timber facade to filter the light and giving the aesthetic value as it harmonies with the natural environment that's surrounded by woods and green. Lastly, curved trusses for the roof structure to create the wave effect. As conclusions, these are some initial ideas that I want to implement in my design, such as green roof that serve several purposes for a building, such as absorbing rainwater, providing insulation, and providing a more aesthetically pleasing landscape. Glass wall at the office area for rainwater fall from the roof to the ground. Besides, I want to have circular staircase and glass wall with the timber cladding that allow the daylight to go through the building. Lastly, using the timber look like pergola for the link from public to private spaces. That's all for the presentation. Thank you for listening.